So we've been looking at projectiles. Sarah, here's what we said our strategy was. For two-dimensional motion for a projectile that's been thrown sideways, we break it up into its horizontal and vertical components. And the best tool I can give you is a T-table. In fact, if you're solving a projectile and you need some help, Karen, and you raise your hand, I'll walk over. If I don't see a T-table, I'm going to walk away. And the two physics no-brainers that we said we can always write in our T-table, horizontal and vertical, AX will be 0, AY will be negative 9.8. The rest, Taryn, will adjust to our question. We also said we're going to carefully list things in the horizontal and vertical columns. Make sure you don't ever put a horizontal into a vertical. Make sure you never put a vertical into a horizontal. Somewhere along the way, you'll know three things. Once you know three things, you can find the fourth. And the joke I said is we'll usually spend most of our time finding time. Why? Because that's the one that can go in both columns because it's both, it's a scalar. So it can go in horizontal or vertical. So we did one launching horizontally from a cliff. I like example 9, I like example 9, I like example 9. Example 9 is a nice question. You're going to see ground at an angle. Did I say angle, everybody? Okay, so example 9 says solve for time to top, total flight time, and the range. Hint, T-table. Before I even do my T-table, I see an angle, components. I'm going to break this velocity up into horizontal and vertical components. And in fact, here's what I'm going to say to you right now. This slanty velocity, this 100, you will never use it. It's neither horizontal nor vertical. David, it can't go in our T-table because it's neither of them. That's going to be the most tempting mistake for kids to make because when they write down VI, they want to think, isn't that the initial velocity? Not in our T-table because it's not horizontal or vertical. Let's break this up into components. I'm going to go like this. D, 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 D. I'll call this Vx. D, 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 D. I'll call this Vy initial. Why did I put an initial on the Vy and not on the Vx? Because only the vertical is changing because it's the only one that has an acceleration. Even just to reinforce myself, Garrett, with that, I'll do that. Over here, I've got some room. I'm going to have to do some trig. Let's see. 100. Oh, color. Hypotenuse. Vy, opposite or adjacent? Opposite? What about Vx? Okay. Let's find, oh, I don't know, Vx first. Cosine. So it's going to be cos 35 equals Vx over 100. Vx is going to be, oh, they're getting their calculators out. Excellent. They might even want their formula sheets. I don't know. 100 cos 35. And I get, because I'm going to use this, I'm going to carry some extra sig figs. You know what? There's a 0 after the 2. I'm going to go 81.9152. If I go to 5 or 6 sig figs, Sarah, then my final answer will be good to 3 sig figs if I go to 5 or 6 sig figs with my data along the way. So 81.9152 works. Is that right? Good. Which trig function am I going to use to find Vy initial? Yeah, by the way, I had somebody ask the other day, couldn't I use tangent? You could, but then you're using an answer to find an answer, and Braden, why not avoid that if I can, if it's easy? So I'm going to use sine. Vy initial over 100. And I get 57.3576. There's a nice place to round off. I'll go to that 6. 57.3576. 57.3576. 57.3576. A wants me to find the time to top, but first I'm going to make a T-table. Horizontal vertical. What are the two things that I can write, my physics no-brainers? AX equals AY equals negative 9.8. I can do that without even reading the rest of the question. Now, let's see. Oh, I guess I can say Vx equals 81.9152. I can say Vy initial equals 57.3576. Sarah, I picked on you yesterday. How many things do I know in the horizontal column? How about in the vertical column? Okay. Is there anything else I can steal from the diagram? I've used that 100 already. Yes? So is there anything else I can steal from the diagram? Say no. All right. I guess the rest I'm going to have to just ponder. What does A want me to find? Keep reading. Time 2. The word top, does that suggest horizontal or vertical to you? Okay, I think I'm already shifting my mind into the vertical column. And so now I'm going to ask, do I know anything at the top? Kai's nodding. What? I'm going to be really fussy. VYF is 0 because it's still moving sideways. Okay? If VF was 0, it would be hovering in place. I'm doing that just to remind you, start to think two-dimensionally all the time here. So, for part A, I can say Vy final equals 0. Hey, two things. Sarah, now I know 3 vertical things. I can find a 4th. I'll quickly rewrite these on this line just so it's a bit easier to spot. In your homework, if you didn't do that, I wouldn't freak out. Let's do that in our notes so we know what data we're using. So we're using the fact that at the top, vertically, it comes to a stop for a split second. And I'd like to find time. So, looking for an equation that's got a VF, a VI, an A, and a T. Oh, you know, it's our old friend, isn't it? It's VF equals VI plus AT. George, get the T by itself.
VF minus VI.
And I'll just remind myself, because it never hurts, vertical, vertical, vertical. By the way, can you see, if you don't realize that it's stopped at the top and you're desperate for a V final, it's easy to take that 100 or make that be initial and make this be final. Just discipline yourself. The information you need, Braden, will be there. Don't put a slanty or a horizontal into a vertical and vice versa. It's going to be 0 minus 57.3576 all over negative 9.8. 0 minus, I'm going to use my answer button because I happen to have that 57 sitting on my screen. So if you don't use your answer button, you might be off by a couple of decimals, but I get 5.85282. And now I'll give my answer to 3 sig figs, my final answer, 5.85 seconds. I'll even draw a box around it just to say that's the answer. Danica, what's B want? Is that okay, Danica? Okay. What's B want me to find? Isn't it 5.85 seconds? Oh, that's the time to the top. How can I find the total flight time, Zach? Okay, so I got 2 options for part B. I'm going to draw a little line like this just so I can say I'm moving to another thought. So for part B, I'd like you to draw a little line in the middle of the page. There's 2 ways to do this. The fact that I've done part A already, I would go like this. T total equals my answer from A times 2. I would totally do that. And I'm going to do that on my calculator. Times 2. 11.7056. Or 11.1 seconds. Most of you know, Mud, that I'm naturally a little lazy. Little. If I hadn't done A already, I would prefer to get to the answer for B in one step. Am I wrong? Oh, you know what? I reversed those, didn't I? Well, that's silly. Thank you, Taryn. 11.7 seconds. If I hadn't done A already, what if I wanted to get there in one step? Well, I know AY is negative 9.8. I know VY initial is 57.3576. I also know VY final, not 0. What goes up must come. VY final is negative 57.3576. I could use that to find time. I don't care which method you use. If you're more comfortable saying, Karen, look, I know it's 0 at the top for a split second, and I'll double my time. My only concern is kids forget to double this answer. When I say find the total flight time, the number of times I've seen kids, you just found half the flight time. So just don't do that. Just to show you that this works, by the way, if I go negative 57.3576 minus 57.3576 divided by negative 9.8, I also get my 11.7056, and then the decimals don't match because I didn't use my answer button. Okay. What else can I ask? Well, what's part C asking us to find, Gabor? Oh, I like what he said, dx, because I think I actually said find the range, didn't I? The range is our synonym for horizontal distance. Okay. dx equals question mark. What was ax?
0.
It's very tempting. Kids want to put the negative 9.8 in there. Don't do that. It's 0. What was vx? That's only 2 things. I need 3 things. Which time am I going to use? Total time. And I'm going to tell you right now, on your test, there's a very good chance I'll ask you to find the range, and there's a very good chance about 1/5 of you are only going to find half the range because you let VF final, VY final be 0, David, and forget to double it to find the total range. Don't do that. So I'm going to use 11.7056. I'm looking for an equation that's got a D, an A, a V, and a T in it. There is one. Gabor's on a roll right now. Did you hear what he said? He said D equals VIT, and then he didn't read how come he didn't read the plus a half AT squared? A is 0. So in fact, dx equals VXT. Spoiler alert, horizontally is always easier than vertically because the fact that A is 0, you lose the quadratic term and your math becomes much, much nicer. It's going to be 81.9152 times 11.7056. And I get a range of 959 meters. Pretty far. Well, 100 meters per second is pretty fast. that all right? So I already said you could try lesson 1, or so question 1. You can try number 2. Three is just a thought puzzle. 4 is good. 5 is good. 6 is good. 7 is good. 8 is good. 9 is good. 10 is good. So far, I've assigned everything. I know. And then from the ultimate review, you can now do those. And I'm going to press pause because I also know several of you had questions from the homework from previous lessons. So somebody was asking from lesson 5, or no, lesson 4, it was the river. This one, number 15. Yes, someone was asking number 15. I'll just bring it up here. You can look if you want to, or just follow along. It says, to the right, we see the top views of 3 motorboats crossing a river. Yes, we do. They all have the same speed relative to the water, so they're all going to have their motor on at the same speed. Which boat takes the shortest path to the opposite shore? Which boat takes the shortest path? Well, it's going to be A, because A is going to travel in a straight line because it's pointing into the current. It won't get across the fastest, but it'll travel the shortest distance. It's going to go straight. So that's why A. Which one's going to reach the opposite shore first? B will. Now, B's going to end up down there, but it's channeling all of its velocity into making the crossing. It'll cross in the least amount of time, but you'll just have to schlep upstream to end up where you want it. Which boat provides the fastest ride? Definitely C, because if I add these two together tip to tail, I have this plus this. I have a long, I can't call that a hypotenuse, but I have the biggest resultant if I add them tip to tail. C, you're going partly with the current. You would feel more wind on your face in C than in any others. So I hope that answers the question for whoever asked that. And there was another question somebody had, and I said I would go over it today. I think it was one of you. Which one was it, Owen? Was it you that asked? No, someone asked. Okay, now I got to remember which one it was. I think it was from lesson 5. Oh, yeah. It was the jet airliner question. Wasn't it one of you guys? Yeah. Help me out. Help a friend out, man. Oh, this one, right? Suppose a jet airliner needs an air velocity of 306 kilometers per... Nice try.
Do you have a chance to see a student today on a time-sensitive manner later on?
I can see them in about 2 minutes.
Oh, yeah, 100%. That's fantastic.
Sure. Yep. Oh, her? First of all, I got to convert kilometers to meters per second. Who remembers the shortcut that we used last year? How do you go from kilometers per hour to meters per second? Okay, you can add that to your blue sheet, not to your yellow sheet. In Physics 12, I'm going to give you the correct units 99% of the time on a test. I just will. Physics 11, we did a bunch of unit conversion. So I divide by 3.6. David, we did that so much last year that most of them just memorized the shortcut. So don't panic, but you can add that if you want to. 85, okay. That's how fast the airplane has to be traveling through the air, not over the ground, through the air to take off. So if the jet's engines can accelerate the jet forward for part A, they want me to find D. Oh, and what's VI of any airplane taking off ever? Yeah, they come to a stop. VF is going to be 85. A is 3.5. You can find D from that, yes? Okay. In B, the fact that I've got a headwind, that means at rest, I'm already traveling 10 meters per second through the air. What that means, Owen, is over the ground, I only need to get going up to 75 meters per second because I've already, oh, sorry, it's a 15 meter per second headwind, not a 10 meter per second headwind. I only need to get going that fast over the ground because the wind was already blowing past me when I was at rest. So it's going to be the same question, but VF is going to be 70. You'll find you can take off faster. For part C, with a tailwind, this is why planes always launch into the wind. You never launch in a tailwind. I'm actually traveling backwards relative to the wind because I've got a tailwind going this way. First, for me, just to get to 0 in the air, I've got to go 15 meters per second. Then I've got to go an extra 85 meters per second. I'm going to have a V final here of 100 meters per second before I can leave the ground. It'll take longer. Is that all right? Little pilot physics for you. Folks, use this class wisely, my angels. You got lots to work on.